Hey everyone, thank you for watching this video. In this video, we are going to talk about how to add BigQuery as a data source in Accelerator Data Observability Cloud Platform. So let's get started. So in this session today, we are going to see what are the use cases of BigQuery that we have seen with different customers in different line of business. And I have picked up example of enterprise data stack and where do we see BigQuery in that and in usual cases. And then what is the architecture of ADOC, Axel Data Observability Cloud Platform, and where does and how does it connects um, with BigQuery data sets, right? So we'll see that from an architecture standpoint, and then we'll talk about some prerequisites for this integration, like whitelisting and some of the other thing. And then at the end of the session, we're gonna see a demo of this integration on the ADOC platform itself. So this will take around uh, I mean, there will be around 4 slides, which will cover the first 4 points, which will take around 5 to 7 minutes to complete. And then the demo will take around 10 minutes to 12 minutes to complete. So let's get started. So BigQuery is a fully managed serverless cloud data warehouse and an analytics platform designed for query massive data sets at scale with SQL. Uh, so it eliminates the infrastructure management complexity while providing high-speed analytics, machine learning capabilities, and real-time data ingestion. That's very, I think we are familiar about, I'll consider the audience is familiar about a BigQuery. It is highly scalable and very fast. You can run queries and you can get the data very quickly from BigQuery, and it is a product which is provided by Google. So in this you in this integration, there are different companies in different line of business which uses BigQuery uh, uh, to store their different uh, data of different purpose. So, for example, financial services, they store it for compliance queries, fraud detection models, the results of those models, financial reporting. Similarly, CPG stores supply chain data, demand forecasting, or sales intelligence data. Telecommunication companies stores call patterns, subscriber behavior, uh, billing data, and whatnot. Then the healthcare and pharmaceutical companies uses it to store the clinical trial data and patient records and regulatory compliance for the use in regulatory compliance. So so there are different purpose, but they all use BigQuery to store their data, which is important for them so that they can drive some business insights, so that they can pull the data into some dashboards. They can they can connect some BI tool to draw some insights. So there are multiple uh, use cases of storing the data, but at the same time, when the data is stored, it is stored for a purpose, and that purpose is only reliable in the real-time market when the data is reliable. And here comes the Axel Data Observability Cloud Platform, which helps the customer in checking the quality of the data that they store in BigQuery, whether that is uh, like long-term sitting data or that whether that is a incremental data. So on Axel Data, user can create policies, and those policies can run on BigQuery, whether that is pushed down or whether that is on Kubernetes on Spark. We'll talk about it. What are these two different engines? So yeah, so for that to talk about in detail, let's move into the next slide, which basically talks about example of any company which has any enterprise company which has a BigQuery in their stack, right? So usually when the data comes either through streaming apps, RDBMS, or some file storages or on-prem data lakes, right? So the data uh, travels through multiple hop in the pipeline using the ETL jobs or ELT jobs. So the first, it comes, generally they call it landing zone, and from landing the data comes to enrichment, and then enrichment to consumption, and then consumption. When the consumption is ready, there will, on all the way right, you will have some dashboards, ML AI models which will consume it from the consumption layer, right? So generally when the data lands, let's say the data is on-prem, right? And when you're moving it on the cloud and it's on GCP, so generally first the data goes into the GCS bucket, which is file storage, and from there, so which you can consider this one, right? So on-prem to GCS, and then ETL jobs will again be taking the data from here and using Spark jobs or maybe some other job, or using some other pipeline jobs. The enrichment of the data happens, and then it gets stored into some enrichment layer, enrichment data sets, right? And then because it has it is also required to have a separate consumption layer, right? So finally, when the data which is only required for BI or dashboarding or for consumption purposes, they go to the consumption layer. And in between, not just three, there can be some other hops in the pipeline as well. But that's usually what we see with GCP architecture. Data comes to GCS, then it goes to BigQuery, and then after BigQuery, the data can be consumed by Power BI, Tableau, or MLAI model or some other dashboard, right? So that's where you see BigQuery. And talking about the architecture of Exadata Data Observability Cloud, so the first part of the platform, which is, so basically it's a SaaS platform, and there are two parts of the product. Number one is the control plane here, and the number two part of the product, like second part of the product, is the data plane. So control plane is something which is completely hosted and managed by Exadata. It has a UI through which the user interacts with the product. User can create policies. User can discover the assets, run the policies, get the alerts, assign the alerts to somebody else, like do the incident management. All of that can be done from the UI that the user gets, right? And that can be accessed through the browser, obviously. So, and then the second part of the product, which is the data plane. So, as part of the product setup in the client's environment, this second part goes into the customer's premises. It gets installed into the Kubernetes cluster. It can be on any of the three clouds, like, or on-prem cloud. You just need a Kubernetes cluster to run on. So it will have a data processing engine and a data processing agent, and then a push down execution mode is also available, which is relevant for BigQuery, which I'll talk about in a few minutes. So what usually happens, so the user that creates the policy that gets stored into the control plane, right? And when the policy gets triggered, let's say it's a data quality policy, which that gets triggered, so that in the form of a Spark job that goes to the data plane, right? That goes to the data plane and it runs, and data plane is basically your Kubernetes cluster. So the policy, which acts as a Spark job at the backend, runs on the Kubernetes cluster, and then it observes all of your records, whether that is incremental. Let's say you are running the data from yesterday to today, right? So the policy is basically pulling the data from BigQuery, which is this. It pulls the data into the BigQuery, and it pulls the data from BigQuery to the data plane cluster on Kubernetes pods. It observes the data based on the rules that the user defines, and then it only sends the metadata to the control plane. So with that approach, none of the customer data moves out of the customer environment, right? So what it requires is basically setting up a data plane in the customer premises, right? And that data plane should have a registered connectivity to the data source. And that is what we are going to see here, how to register that or how to add the BigQuery data source. So basically, we will do this registration, or we will just see how the registration needs should be done, right? And so that's basically one approach in checking the quality of the data, which sits on BigQuery. The another approach that is called push down approach is basically uh, the second option of doing data quality on the data that sits on BigQuery, right? So in that picture, in the second option, this data plane is not required, right? So what happens from the control plane itself, the query, the policy which you created from the UI, that does not get converted into the Spark job. That actually goes as a query directly into the BigQuery. And the query runs on and the query will have basically the checks and everything defined. And you don't have to write that query. That when you create the policy from the UI, that the product itself basically converts the policy into that query, and the query basically goes into the BigQuery data set here, and it runs over here on the BigQuery cluster itself, and only the result goes to the control plane, right? So in the first approach, it utilized the compute power of data plane, which is the Kubernetes cluster. And in the second approach, the query is basically utilizing the compute power of BigQuery itself, right? So these are the two approaches, which is basically the first one is the pull up approach, where the query goes into the Kubernetes cluster. And the second approach is basically push down approach, where the query directly goes to the BigQuery data set itself, a BigQuery environment itself, and it just gets the metadata out of it. Okay. So moving on, we'll talk about how to basically on where when we see that on the demo, because after this slide we'll go into the demo now, and we'll see how to basically select either option 1 or option 2 that we will see in the product demo itself. So what are the prerequisites for this integration? On a very high level, you need the project name, you need the dataset name. So project name is basically the project under which your data sets, your BigQuery data sets are present. And then you need the name of the data sets, obviously. That's number one. Then you need to authenticate. So you either authenticate via Google workload identity, or you can authenticate via the credential file, which is basically a JSON file. And then you need to have the communication whitelisted between the BigQuery and the ADOC data plane, right? So communication between this and this has to be whitelisted, right? Again, if you're using the first approach. But in detail, if you want to have, that's the minimum requirement. But depending on which approach you go, there is a detailed document which is present here, right? If I open it up here, so this is the document that Axel Data has in the Axel Data's documentation site, right? So these are the prerequisites that's for BigQuery integration with ADOC platform. So at a minimum, you need the data source project, right? That the project name, right? And then you to basically have if you want to run the query on a Spark cluster, then you will also require some, depending on that, you'll need some temporary projects as well, right? And then the third piece here is the service project. It is recommended to have separate service project in order to maintain or improve the security or operational clarity. Uh, but this is basically optional if you're going by the second approach, right? So it is only required when you are using the Spark engine. If you're using push down, it is the temporary project is not required, right? And I'll show you where do you provide the temporary project name. So Why is it required? What IAM roles is needed in case of this is also mentioned here, and then a detailed step of how to add this data source in the platform is also mentioned here in the documentation side. But this is what we are going to cover now. So let's move into the platform and see how to basically uh, add this data source. So first you go into the register section here, this icon, register icon, and then you will find the list of data sources which are already added. You'll find a option to click on add data source on the right top here. Once you click on this, you will find the 4550 connectors that Axel Data has out of the box, right? And from here, you will basically select your data source, which is BigQuery, and you provide the name, you enable data reliability, and then you select the data plane, right? So if I have to show you a created example which is already there, okay. So that's the name of the data source, and then a data plane is already there. I've selected the data plane, and obviously the whitelisting has to be done between this data plane and the BigQuery data set. So yeah, if you want to use to authenticate, if you want to use workload identity, you enable that and you complete that. Otherwise, you upload the credential file, right? And this is my credential file to access my BigQuery project, which is Accelerator-ACM. That's our internal project. And then whether you want to use Spark or Pushdown, right? So this is where you basically select whether you want to use the Spark engine or you want to use the Pushdown engine, right? So once you select one engine and you do, I'm sorry. So I'll just do a pause here. Okay, yeah, the connection is successful. Now going to the next page here. So uh, here I have to basically provide the temporary project name. Temporary project name, if you're using Spark engine, so it is required to provide the temporary project name, but since it is an internal thing, we have not mentioned it here. But in a production environment, it is good to have to maintain the security thing. We basically have to have the temporary project name and the temporary data set, right? So that we only access the temporary project, not the actual project that the BigQuery has. So, and then the data sets names are that you want to where the data is actually stored. So temporary data set is basically through which you will have access and through which the communication will go through to your actual data set where the data is actually present. So in this case, these are the data sets, right? And I want to monitor the data which is stored here. And then after that, I have enabled query analyzer, query analysis, which is basically which looks into the query and basically draw the lineage by um, by looking at the query, what should be the lineage, what should be the upstream or downstream asset, right? That's a feature that comes through not with all data sources, but it is available with BigQuery. And then this is the option to schedule your to schedule your query analysis. And if you want to enable query, sorry, crawler execution as well. So you can schedule to run your crawler job either weekly, bi-weekly, or daily or hourly basis, right? Yeah. So crawler is basically the job which is the first job after the connection setup. It gets the metadata out of the data source. For example, how many databases are there, how many data sets are there, how many columns are there, and what are the name of those columns. So that's a metadata that comes, and that's not a very heavy lifting job. Uh, and it just gets the schema related details from the data source, right? And let's say if you want to track the schema changes, right? If the schema of a particular data has changed and you want to get a notification, in that case, you have to schedule this crawler to run it on a frequency, so that in that frequency, if that changes, so you will get notified based on that. And then the last option here is to notify if the crawler fails. So you have the option to create a notification channel, which can be your email, Slack, webhook, or Jira, ServiceNow, right? You can do incident management over there as well. We have bi-directional integration. And then if you want to get a notification even in the case of success, so you enable that toggle button. Once all of that is done, I'll just I will not I will just submit this, but I will not start the crawler, right? One second. So as soon as you save, I'll because I have already run this in the past, so I can show you what uh, data that it brings. So if you click on the So first, if the crawler completes, right? So you will get a notification that your crawler has completed a minute ago. The last execution of the crawler was 4 days ago. If you want to check the execute how much time it has taken to complete, so you can go directly here. Uh, Sorry, uh, I have a permission issue here, but you can check the crawler status if you have the right permission here. And then if you want to start the crawler again, you can start it from here, and it will refetch the metadata again. And if you want to check what the crawler has fetched, so what it says is basically there are around 4 SQL views, 6 data set, there are around 84 table, 7 views, and the rest of the details are mentioned over here. So if you want to check, okay, I want to get into the list of 4 SQL views, I want to see that. Or if I want to see the list of tables that I have, so I can click on table and I can go directly here, right? Or I can go to the navigator and I can basically expand it from here and see based on my data sets, what are the assets that are present there, right? So if I want to see, okay, if I want to see this one, right? So let me just do a little, right? So what it says is basically regarding this data set, right? If I want to see what are the data sets here, how many policies that are configured here, so there are no policies here, but if I want to see vehicle demo, uh, or this is just a example that we have created for for demo purposes. So there are three data sets under this three data sets under this vehicle demo. One table is vehicle sales, another one is vehicle data, and for Ford model SRP. So what are the open alerts here? What is the reliability score? there are no tags currently assigned, or connect or how many data quality policies are running, how many reconciliation policies are configured here, freshness policies are configured here, anomaly policies, how many total records. So these are the metadata that it fetch, right? But all of the policies that you see is basically user defined policy. So user has to set up these policies for for the first time, and then have it running for an incremental basis. If I just go into any one of these and just check out the details from here. So you have a bunch of options to basically get more details around this table, which is vehicle sales, right? And what is the reliability score? And this is where I was referring. In order to know whether your model which connects to this data set, right? This could be a data set of your consumption table, and your Power BI or Tableau or some BI reporting tool is connecting to this data sets. And if this data is not reliable, right, your all the insights that you draw from that BI will also not be reliable into the real time market. So how reliable is your data? It's 99.98%, but how do we say that it is 99.98%? It is the consolidation of all of these scores that are present here. What is the score of freshness? How fresh is your data? Is the data landing on time? Is the data landing with right size? So that's basically score of that. And similarly, there are different other scores. And finally, you get the reliability score, which gives you the confidence on having how much confidence you should be having on a particular data sets. So that's about this integration. I'll come back to and just quickly summarize what we have just done. We started from the registration page. We basically saw how to add, how to find the list of data sources, that connectors that are available, and you select a BigQuery over there. You provided a name, enable data reliability, and selected the data plane that assumingly that is already there. So so after, I mean, this integration only works after the data plane is deployed, whether you use the push down mechanism or whether you use the data plane engine, right? The data plane setup is required. And then the next step here is to provide the credentials file for authentication, and provide the project name, or select the engine, which whether you want to use the Spark engine or push down engine, and then provide the data set, temporary data sets, uh, start the crawler, save the configuration and start the crawler that will ingest the metadata into the control plane. And once the crawler is completed, check the status and then verify whether it has fetched the right details, right? How many assets are there? How many records are there into those assets? How many columns are there into those tables? So all of the details we have seen how to check that. So that's about the today's video. We'll see you into the next session. Thank you.